Right, so the PE headers one, you're just going to analyze a program. So you make a simple program, hello, that just has print hello. This is hello world. It just is a C++ code. You compile it yourself with the Microsoft Visual Studio compiler, which is CL, the command line compiler. Then you have a simple executable, and now you can just analyze it here with this PE view. You can see how the start of a program is always the DOS signature, which is MZ. Every Windows program has to start with that. This is for the old MS-DOS program, the first header. This is a useless stub these days. Then you have the new EXE header, which is the image NT header, which starts with PE, is the signature. Portable executable is the new format since DOS. And then you have a time date stamp here, which is useful to determine when it was compiled. And then you have an image optional header down here, which we're going to see in here. You have all the information about how it should put this code in memory. So the image base is here. That's where it's going to go in memory. It'll try, all Windows programs typically try to load at 400,000. They all think they're running at 400,000 at virtual address. They'll try to load here. Then it has the size of the image is down here. That's how big it's the total size of all sections in memory. And then there's an import table. So this is just, that's why you have the header. The header tells it how to take this disk file and load it into memory to run. And it has to build the various sections, text, data, RData, and whatever else you have. And so down here, you have an export table. And so you can see the import address table here. These are here's the import address table at this address. And so what you can do, you can look at the header and you can see where it's going to put these things in memory. So the section headers are here for each section. You're going to see virtual size, where it's loaded into memory, and the size. So here, for example, is the text section. Its virtual size is F8A8, and its size of raw data is F800, and it's going to go in memory at the RVA. This is the relative virtual address, where it's going to load 1,000 bytes past the start, which was 400,000, defined earlier. So this is why, if you look at it, I think I still have, in fact, I think I still have Ollie open. You can see this nicely in the memory map in Ollie. If I view memory, okay, there, you see the program starts at 400,000. Then the text section is 401,000. Then comes RData, data, and sync. Each one of them is a certain number of thousands ahead. They're rounded off to near thousands. That's what the PE header is for. It tells it how to load all these sections in. And every Windows program tries to load at 400,000, and then it puts the text section at 401,000. So there are gaps. There's wasted memory in between. That's how it works. But it loads these into memory, and that's all defined by the header. The header tells it how to load that stuff. So there are some programs here you can try. And by the way, there's a program called CFF Explorer if you're using my pre-made machine, which is very handy to fix broken files. It will actually see if any of these is wrong. Now, see, the original time, in the early days, I did this project, and I changed some of these header values. Some of these addresses are wrong, so the program won't run. And you have to find the broken one and fix it. And that's cool. You can do it with this program, PEView. But if you use CFF Explorer, it gets really easy, because CFF Explorer will turn everything red if it looks funny. So you can easily see these memories. I don't have it on this machine yet, so I can't demonstrate it live. But that's what you got, a series of files you'll try to fix here that have broken addresses in the header. So that's all I wanted to tell you about that one. Let me stop this recording.